Okay, I just want to put some experimental commentary on this really good page by Chem Libretext's Polarisation. I always knew that calcite does double diffraction, but I only just read this, and it polarizes it at perpendicular planes, which is really cool. So you can have a look at the calcite here. You can see that it's refracted, and it's refracted twice. So the calcite word has shifted, and it's shifted in two different places. But not only that, it does that by splitting the light up. And so one of them's in one direction, one of them's in the other direction. And you can see by turning the sunglasses that one of them disappears and the other one appears. So let me just backtrack a fair bit then. And this just page is just so good. I just can't beat their diagrams. They're just really good. Okay, so first of all, light is an electromagnetic wave. So all of this can be polarized, like X-rays, microwaves, infrared, ultraviolet. All of different types of radiation, electromagnetic radiation, can do this. And so what electromagnetic radiation is, it's an electric wave and then a perpendicular magnetic wave, and then there's like an infinite number around here. So there's these, they're also just, at different angles as well. Now, the only reason we care about the we just ignore the magnetic one now, because the electrons are the ones that interact with the electric wave. So you can see here with the Polaroid lens, what's happening is they're molecules that are all lined up, and the electric wave will interact with the electrons quite well along here and get absorbed, but not so much if they're going up and down. And so that's how the sunglasses work, how they polarize the light. And so they allow the light that's up and down if it's if it's in this direction. And so what you're going to see is when you polarize the light, it goes up and down, right? But if you do them at perpendicular angles to each other, it gets blocked. And so you can see that there with the calcite word. I'm just turning it around, and you can see once they're at right angles to each other, it blocks everything. Okay, and you can see that with your screens as well. And so I'm showing you here that all your computer screens are polarized. So if I just take one lens and put it at 90 degrees, whatever that is, I'll just rotate it around till I find that angle. Then it blocks it out. And so what the really cool thing is you do that with the calcite. So you know that one of the calcite words is at one angle and the other calcite's at 90 degrees. So you just turn the lens 90 degrees and one of the words will appear and the other will disappear, all right? Because the light's been polarized at two different angles by the crystal. Okay, so I thought that was really cool, and I'm a little bit annoyed I never knew that before.